So we are going to talk about different angle relationships in circles. And we're going to be adding a couple more from what you already know, and then we're going to be doing a quick recap at the end. So the first theorem is 12-5-1, if you want the number. And it says if a tangent and a secant or a chord intersect a circle at a point of tangency, then the measure of the angle formed by it is half the measure of its intercepted arc. So the main part with this is that it's hitting at that point of tangency. And so when that happens, it's going to be half the arc. So you have measure of angle ABC is equal to 1/2 the measure of arc AB. Now, let's say they give you the angle measure instead. Then to find your arc, you would just do 2 times the measure of angle ABC to get the measure of the arc. So it's just opposite. Okay, so it's kind of like oh my gosh, I just had a brain fart and totally forgot the word. It's kind of like the inscribed angles, but obviously one of the lines is tangent this time, but still the same rule as the inscribed. So if we want to find the measure of angle EFH, we'd go E to F to H. So we're talking about this angle in here. So it is going to be half the measure of the intercepted arc, which is this 130. So 130 divided by 2 is 65 degrees, and that is it. 60. Ooh, goodness, I don't know why I can't write today. 65. There we go. And so then if we wanted to find the measure of arc GF, we'd go G to F. And you notice with this one, we have this 122, but that 122 corresponds to this arc. So in order to do this, I see this straight line and I'm like, hey, these are supplementary. So 180 minus 122 is 58 degrees. So now I know this angle is 58. So if I know the angle is 58, I'm just going to be multiplying it by 2, times 2, which gives me 116 degrees. Okay, so same idea, different problem. If we want to find angle STU, we'd go S to T to U. And if you notice, we were looking at this 166 degrees. So because we're going from the big arc to the smaller angle, we're going to be divided by 2. So 166 divided by 2 is 83 degrees. So then for arc SR, that would be S to R. The nice thing with this one is we know it's the 71 degrees. So we're just going to take that and multiply it by 2. So 71 times 2 is 142 degrees. Okay, so that should hopefully be pretty straightforward. The only thing that might be strange is the pictures. So then our next theorem is 12-5-2 if you want the number. And again, this just helps you reference in the book. But if you have 2 secants or chords that intersect in the interior of a circle, then the measure of each angle formed is half the sum of the measures of its intercepted arcs. So if you notice with angle 1, we have 2 arcs that intercept it. We have this one, and then you also have this little arc over here. So because of that, we know that the measure of angle 1 is going to be 1/2 the measure of arc AB plus the measure of arc CD. Okay, so you're just adding them together to figure it out. And one way to remember it, to know that you use both of them, is that angle 1 is going to be congruent to this angle that I just drew the pink dot on because they're vertical angles. So just think of them as the same thing. So you're taking both arcs into consideration. So actually solving this, if I want to find the measure of angle AEB, we'd have A to E to B. So this is going to use that previous theorem. So my intercepted arcs are going to be this 139 and this 113. And again, if you notice with that vertical angle, we are making this arc DC and we're looking at arc AB. Okay, so in order to do this, we would have 1/2 times each of our intercepted arcs, so that'd be 139 degrees plus 113 degrees, which would give you 1/2 of 252 if you want to have that middle step, which gives you 126 degrees. for that angle. And a really easy way to check it is just ask yourself, is it an obtuse angle? It is? Then chances are you're probably on the right track. So then to find AED, that would be A to E to D. Because I know this angle is now 126 degrees, I can find AED pretty easily just by using supplementary angles. 180 minus 126 gives me 54 degrees, and that is all. So don't forget about the simple rules of supplementary and stuff like that, because it can make your life easier. Okay. So going on, measure of angle ABD, we'd have A to B to D. So we're going to be looking at this 65. And if you look at its vertical angle, we're going to be looking at this 37. So because it's inside the circle, it's going to be added, and we're going to take half of it. So we'd have 1/2 times 65 plus 37. And 65 plus 37 is 102. Which gives you 51 degrees. Okay, so I know this is 51 now, and this one's also 51. So that if I want to know the measure of angle ABE, ABE is A to B to E. So it is, again, supplementary. So we'd have 180 minus 51, which gives us 129 degrees. So again, supplementary angles can be extremely helpful to you in this. So for this one, we want to find RNM. So R to N to M. So this little angle in here. So if you notice, we have no arc measurements for this angle. But because we've been using those supplementary angles, we do know that it's supplementary to this angle right here. And for that angle, we have 91 degrees and 225 degrees for its intercepted arcs. So we can find the measure of MNQ, where the blue dot is, and then we can just subtract from 180. So to do that, we would have 1/2 times 91 plus 225, which should give you 1/2 of 316, which is 158 degrees. So then, because I know it's supplementary, I'm going to have 180 minus 158, which gives me 22 degrees. Now, if you really wanted to, there is another way you could do this, and it may or may not make sense to you depending on how well you're understanding these circle stuff. So another option is if you look at the entire circle, I know that the entire circle has 360 degrees. So if I take that 360 degrees, the only pieces, because I know 91 and 225, I have this piece and this piece, that if I subtract those two angles, I have the sum of those ones. So I would subtract 225 minus 91, and that gives you 44. So because I have 44, even though I don't know how much of that 44 is QP and how much of it is MR, it doesn't matter because we still want just half of that sum. So this 44 is the sum of the arc MR and QP. So then I'm really just doing 1/2 of 44, which is 22 degrees. So whichever method you prefer, I'm fine with either. But just make sure if you use the method in the orange that the arcs that you subtract will give you just the sum of the arcs that you need. Okay. So our next theorem is 12-5-3. And this one has a lot of possibilities in how it can be made. You can have a tangent and a secant, two tangents, or two secants. But you notice it's all just a bunch of lines outside of a circle. But these, if they hit or intersect in the exterior of a circle, then the measure of the angle formed is half the difference of the measures of its intercepted arcs. So if you look at the examples, measure of angle 1 is AD minus BD. And that's just finding the difference and taking half. For measure of angle 2, it is EHG minus EG. And then for measure of angle 3, we are doing the arc JN minus the arc KM. and then you're just taking half. So it's really similar to what we were just doing, except instead of adding, we are now subtracting. So actually using this, and actually what might help you too is if you just write yourself a little note. Outside angle, outside circle, subtract. So if we look at example 6, we have that we want to find the measure of, or find the value of x. So if you notice, we have 74 degrees and 200 degrees. And so remember, when you're subtracting, you're always going to subtract the bigger number first, or have the bigger number first. So we'd have x equals 1/2 of 200 minus 74, because again, they're outside, they're getting subtracted. So that would be 1/2 times 126, which gives you 63 degrees. Okay, and literally that's all you have to do. So then if we look at, what in the world? That's weird. When we look at example 7, we want to find this x degrees, but if you notice, the difference between example 7 and example 6 is in 6, the x degrees was on the outside, and notice x was by itself in the equation. Now x is on the inside because it's one of the arcs, and we already know the measure of the angle. So you're still using the same formula, just plugging them in differently. So because I know that these are my arc measurements, that means that my angle is 25 degrees. So I'm going to have 25 degrees equals half the difference of my arc measurements. So 83 minus x. And then you're just solving an equation using algebra. So personally, I would multiply by 2 first, because that'll cancel out that 1/2. Boop, boop. So then you have 50 equals 83 minus x. Then I would subtract 83, which gives you negative 33 equals negative x, and then divide by -1 to get x equals 33 degrees. And if you want to check it, you just plug it back in, do 83 minus 33, which gives you 50 degrees, and 50 divided by 2 gives you that 25. So we are good to go. So for number 7, same idea. We are looking at our arc measurements are 87 and 7, and we have this x out here by its onesies. So it's going to be like example 6. So we would have x equals 1/2 big arc minus baby arc. So that gives us 1/2 of 80. So x is 40 degrees. Okay. So then looking at example 8, I don't know why the box is randomly floating down. I imagine it's going to disappear here in a second. Maybe not. I thought it was. Oh, nope, it actually traveled with me this time. That's silly. Okay, so technology is funny. So in example 8, if the company logo shown measure of arc FH is 108, so F to H, and I'm going to go a little bit closer to the H so it's a little bit more obvious, that is 108 degrees, and the measure of arc LJ is 12 degrees. And we want to know what is the measure of FKH. And if you notice, FKH is this angle right here. So because we're looking for an angle, it's outside the circle, so we know we're subtracting the arcs and taking half of it. So I will personally just abbreviate FKH as just K, because K is the vertex. So K is 1/2 of 108 minus 12. 108 minus 12 is 96. And then half of 96 is 48 degrees. So if you want to write it, measure of FKH is 48 degrees. Okay. So example 2, 2 of the 6 muscles that control eye movement are attached to the eyeball and intersect behind the eye. If the measure of arc AEB is 225, and the measure so that is 225 degrees. We want to find what is the measure of ACB, which is right here. So if you notice with this ACB, we would need to know what this other arc is. And if you notice, there's only 2 arcs on this circle because we have our 2 points of tangency. So this makes your life a bit easier because all you have to do to find your other arc is 360 minus 225. And that tells us that this arc is 135 degrees. And I will, there. So now that we know that, now we can just plug it in. Again, I'm going to use the vertex of the angle. So C is 1/2 of 225 minus 135. By the way, if you were half tempted to do, the sum of these is 360, so half of 360 is 180. Remember, that is only for angles inside of the circle. So this would be 1/2 of 90, which means that the angle is 45 degrees. So the measure of angle ACB is 45 degrees. All right. So we have this table, and this is just kind of to put it all in one place for you to make your life a little bit easier. So we're going to start with where is the vertex of the angle? Start with the first one we did. The vertex is going to be center of the circle. Now, I'm going to kind of bounce back and forth. So if I were to have a picture for this, I would have my circle, I would have a center, and then my angle would be like angle 1. So I'm going to just add that this arc up here is 40 degrees so that I can help me set it up. So if my vertex is at the center of the circle, then the measure of the angle is the same as intercepted arc. And by the way, feel free to try and fill this out on your own. If you just want to see the fill in of the first column and then fill it in on yourself, that's fine. You can check yourself. So because it's the same, I know that the measure of angle 1 in this case is 40 degrees. And yes, I just picked numbers. That's fine. We're just setting an example. So then if my vertex of my circle is, let's say, on the circle, and if you want to be specific, you can say it's inscribed. Then when you draw your picture, boop, and I'm going to use green for all my angles. Boop. We're just going to keep using angle 1. I'm going to say that this arc is, let's say, 60 degrees. So if it is on the circle, it is half of your intercepted arc. So in this case, my measure of angle 1 would be half of 60, which is 30 degrees. Okay. The next one we have is stuff that we did today. So if we have if the vertex of the angle is inside a circle, my picture for that would be something like this. And mind you, it can be chords and secants or tangents or whatever. Here, I'll make it a chord and a secant. That way it's a little bit different. And let's say we wanted angle 1 and we knew this one was 86 and this one over here was 44. The measure of the angle is going to be half the sum of intercepted arcs. So in this case, measure of angle 1 is going to be 1/2 of 44 plus 86. So then the measure of angle 1 is going to be 65 degrees. Okay? And then our last little box, we've been inside a circle. Now we're going to go outside the circle. Oops, I don't want green. I want the purple. Outside. So if we are outside the circle, it's half the difference. I had to smush it a little bit, of intercepted arcs. So in a picture, it would be something, maybe we have 2 secants. Measure angle 1 is going to be right here. If we know that this is 45 degrees and this one is, let's say, 125 degrees, the measure of angle 1 would be 1/2 of 125 minus 45. So the measure of angle 1 is 40 degrees. Okay, so now you have a table with all of your angle relationships, so that's your cheat sheet. So if we want to find arc measures, this is where you're going to have to put your problem solving hats on, because you're going to have to sometimes take an indirect route to find the measure of the arc. So we want to find arc YZ, which is this one right here. So when I look at these, it's just like a puzzle. So I try and just fill in whatever information I know. I know that this 113 makes this angle over here also 113. And that is going to be helpful because in order to find this, I'm going to have to know both arcs, right? Because we're going inside these angles are inside of the circle. So what I would do first is try and figure out how we can find, oh my goodness, why can I not think? I want to find what this little bit is. Because if I find that little bit, then I can hopefully get my other pieces to cooperate so I can actually solve this for it. So, and I realize that I'm probably super confusing you, so I'm sorry. But my first piece to this, and I'm just going to number the steps, is that when I look at this 113, I want to know what this angle is too. So I'm going to do 180 minus 113, which gives us 67 degrees. Okay, so I know both of those angles are 67. So since I know that, I can figure out what my bright blue highlighter is because I have the angle and I have one of the arcs. So I know that my angle is 67, and it is, because it's inside, is going to be the sum of the arcs. So I'm going to have 68 degrees from arc WZ plus arc, and I'm going to just give it a letter so I can actually refer to it. I'm going to say YA. And if you want, you can just use an X instead, but when I did the notes the first time and I put an X, I kind of confused myself on what arc I was talking about. So feel free to put the actual arc name in there if you want. So to solve this, I would multiply by 2 to both sides so that it cancels out the 1/2. So that gives me 134 equals 68 plus arc YA, which again, I picked the A. So then when I subtract that 68, I find that that arc is 66 degrees. Okay, so now that I have that one, I can use that to help me refer to or find the YZ, because now and I'm going to use colors a bunch for this. Because I have that 49 degrees, and because YZ is one of the intercepted arcs, I now have at least one of the intercepted arcs, so now I can solve for the other. So now, actually let me draw a little line, boop. Okay, so now, step 2, I know that because that angle is outside, I need to find the difference of my intercepted arcs. Because my periwinkle one, this one with the red, is the bigger one, I know that one's going to be first, so I'm just going to say arc YZ minus 66. So again, I'm going to multiply by 2 first, so I can get rid of that fraction. So that gives me 98 equals arc YZ minus 66. And then when you add 66, you get that YZ is 164 degrees. Now, maybe you're thinking, oh my gosh, Miss Hall, I have no idea what just happened, and I just want to check it. So, check it. We certainly can. If I want to check, all you have to do is plug in something you know. I know this 113 degrees is going to be the sum of my big arc plus my other arc. And really, I didn't write it down, but if we were to subtract from 360, I know that this one would be 62 degrees. So then, oops, plus 62, I get 113 equals 1/2 times 226. And half of 226, wouldn't you know, is 113. So we are good. All right. So now if I want to find the measure of arc LP, LP is this one. And they tell us that LR is 100. So I'm just going to do a little blue. So LR is 100. Okay. So what I notice is that with these arcs, I can hopefully figure out what this arc is because I know the angle and the big arc. So if I can find that piece, then I can use the fact that the big arc is 100 to subtract the one I solved for. So if I start, and actually I'll use the green first because the green is what corresponds to what I'm talking about. We have first part, this 26 degrees. Because it's outside the circle, I am going to be subtracting my arc. So I'm going to have 80 minus arc PR. Again, you can use an X if you prefer. I like to just have it here in this case. So I would still multiply by 2 to cancel out that 1/2. So that gives you 52 equals 80 minus arc PR. So then you would subtract the 80, and that gives you negative 28 equals negative arc PR. So then when you divide by that negative, you get that arc PR is 28 degrees. So now that you know that that's 28 degrees, now we're on the uphill battle because the measure of LR, which is the big one, is going to be equal to LP, the one we're solving for, plus PR, the one we already know. So if we plug in what we know, LR is 100, LP is our unknown, and PR we just solved for is 28. So when you subtract 28, you get that LP is 72 degrees. So, like I said, these are a bit like puzzles. So I recommend just looking for any relationships you can find. Your worst case scenario is you're just trying to find everything. But try and focus your attention on the arcs that you actually need. You do have some homework on page 834 of your book. So if you have any questions, feel free to ask, but I would definitely make sure you have this table filled out because it's going to make your life a whole lot easier if you have all those in one place. So if you have any questions, feel free to ask. Otherwise, we'll see you next video.